All right, so let's look at the next example. We have 81x squared minus 18x plus 1 is less than 0. So we have a trinomial. This happens to be a perfect square trinomial. Because the first and last terms are perfect squares. The sign of the last term is positive. That's what we want. Should be equals to 0. So remember, a perfect square trinomial, the first and last terms will be the same. Break down 81x squared, we have 9x, 9x. Break down 1, we have 1 and 1, and then we have the same signs, a minus and a minus. And since the 9x minus 1 is being repeated twice, we only need to write one solution. So add 1 to each side, then divide by 9, we have a solution of 1/9. So here's our number line. Let's find 1/9. This is our boundary point. You don't need to write it twice. So 1/9 is equivalent to 0.1111. So we can find a value to the left of 1/9. Let's say when x is equal to 0, and then we can say when x is equal to 1. Okay? And let's check to see if either side is true. So go back to our original. We're going to check. Original inequality, we're going to substitute 0 in for x. So we have 81 times 0 squared minus 18 times 0 plus 1 is less than 0. 0 minus 0, that's 0 plus 1. 1 is less than 0. Is this a true or a false statement? Is 1 less than 0? That is false. So we're going to say false here. Okay. Now when x is equal to 1, checking our boundary point here from 1/9 to positive infinity, or beyond the boundary point there, we have 81 times 1 squared minus 18 times 1 plus 1 less than 0. Therefore, this will give us 81 minus 18 plus 1 less than 0. And 81 minus 18 is 63. And then we add 1. We have 64. Is 64 less than 0? Think about your number line. That will be false. So both sides are false. And because both sides are false, or since both sides are false, what do you think the solution would be? There isn't one. So we would say no solution. We can use this symbol, or we can write out the word no solution. Next example. We have here 5x cubed plus 4x squared minus x minus 4 is greater than or equal to 0. So we're going to solve the equation of this. Whenever we have 4 terms, what's the name of the factoring method? Factor by grouping. Where we're going to split in half, group the first 2 terms together, factor out a GCF. We're going to factor out an x squared, and then we have x plus 4. Then the last half, we're going to factor out a -1, and we have x plus 4 equals to 0. Since we have a common x plus 4 here, we are going to Fact out the common binomial, which is x plus 4, and what we have left is x squared minus 1 equals to 0. Then set each factor equal to 0 and solve. And we have x is equal to -4, and then this equation we have x squared minus 1 equals to 0, therefore it's going to be x squared is equal to positive 1. Since we have a power of 2, we want to take the square root of x squared, so the left hand side we have x is equal to, we're using the square root property here to solve for this equation, therefore we're going to have two solutions, plus or minus 1. So here's our number line. We have -4, we have -1, and we have +1. So we want to highlight all of the true areas. So we have our boundary points, -4, -1, and 1. So let's plug some values in before the -4, between -4 and 1, between -1 and 1, and after the 1. So I'm going to say when x is -5, when x is -2, when x is 0, and then when x is +2. It can be any number, but it has to be between those allotted boundaries, those settings there. So let's check. When x is -5, we have the quantity of -5 cubed plus 4 times -5 squared minus -5 minus 4. Will that be greater than or equal to 0? So here we have -125. Then we have 25 times 4. That would give us plus 100 plus 5 minus 4. Is that greater than or equal to 0? So -125 plus 100 plus 5 minus 4. That gives us -24. So is -24 greater than or equal to 0? True or false? That would be false. Okay. So next, let's check when x is, let me put F here for false. Let's do the next one. When x is equal to -2, we have the quantity of -2 cubed plus 4 times -2 squared minus -2 minus 4. Is that greater than or equal to 0? We have 8 plus, this is going to be 4 times 4, 16, plus 2 minus 4, greater than or equal to 0. So let's do this. 8 plus 16 plus 2 minus 4, 22 greater than or equal to 0. Is that a true statement? Yes, so we're going to say true here. So between -4, and we're going to use brackets because our question has the inequality of greater than or equal to. So -4 and -1, those values are true. When x is equal to 0, 0 cubed plus 4 times 0 squared minus 0 minus 4 greater than or equal to 0. So this is going to be 0 plus 0 minus 0. That would give us is -4. Is -4 greater than or equal to 0? True or false? Let me put true here. This will be false. So there are no true values here, so we do not set the boundaries for that example, or for when x is equal to 0. And then when x is equal to +2. 2 cubed. And let me go back here because you probably saw a mistake here. This 8 should be -8. Let me stop. Let me correct right now. This is what I would do in the classroom. This would be 6. But it's still a true statement, 6 being greater than or equal to 0. All right. Okay, I'm glad I caught this before I ended the video here. So we have 2 cubed plus 4 times 2 squared minus 2 minus 4. Is that greater than or equal to 0? So we have 8 plus 16 minus 2 minus 4 greater than or equal to 0. Is 18 greater than or equal to 0, true or false? That is true. So that notation would be open bracket 1, comma, infinity, close it with a parenthesis. Now, let's write our final answer all together. And that is -4, comma, -1, union. Both of those are open and close bracket. Union, open bracket, 1, comma, infinity. There we go.